So first, distributed the three halves and -1/4, and then after I did that, I multiplied everything by the common factor of 4, so I could get rid of fractions. And then after that, I just combined like terms, and then I just solved the Z after that.
Does anyone have questions or comment on the work that you did? So I'll keep that so then I can make sure I
Oh,
agree.
should I just leave it
Or you can just leave it right there.
Alright.
That's fine. Nice job, Colin. Colin, not too painful, correct?
Yeah, it wasn't that. When you know what you're talking
It's just foreshadowing.
Hannah has number 9, which was one of the equations that were the rational equations.
Sorry, my work's a little bit messy. So I started off by, I rewrote the equation right here. So they both have, this has 2x plus 1, this has 2x minus 1. And to start that, you have to have both of the same bottoms. So I put them all over that, and I multiplied the top by 2x minus 1, because the bottom didn't have that. And then I multiplied that fraction by 2x plus 1, because the bottom didn't have that. And I just put it over 2x plus 1, 2x minus 1. And then that was the equation that came out on top, and then that, and then you multiply the other side because you have to, and you multiply this side by 2x plus 1, 2x minus 1, which cancels it out, and then you multiply that side by 2x plus 1, 2x minus 1. And then you get that equation, and then I solve to get 11 over 6.
Nice, good explanation. Thanks. Any questions for Hannah? Nice job.
Let's just play.
All right, are there other questions from the homework that you would like to discuss? You said 14? So if you'll take a peek at number 14, the question wants you to find both intercepts algebraically and graphically. And then it also asks you to sketch the graph of the equation, which if you needed to use the calculator to do so, especially for number 14, you could have made a quick little t-chart if you wanted to do that as well. That extra x in the front kind of changes that graph a little bit. Let me try this again. Okay. So 14, we have x and then the square root of x plus 2. And the y-intercept, to me, is always the easiest one to find. Emma, why would the y-intercept be the easiest one to find? Yeah, it's already in y equals form. So you don't need to get the variable by itself, because it is by itself. And what are you plugging in for x there, Emma? 0. Yeah, just a 0. And 0 times the square root of 2 is still 0. So this y-intercept is at 0, 0. But we also need to find an x-intercept, and the x-intercept is found by setting y equal to 0 and solving for x. So we have 0 equals x times the square root of x plus 2. how would you solve for x? Okay, so she said you would square the right side of the equal sign. So this side over here? Is that what you're saying? And why are you squaring the right side of the equal sign? Yeah, to get rid of the square root part. And when you do that, this becomes x squared. And then this part right here becomes x plus 2. So the little square goes to both pieces, anything that you're squaring. So that eliminates the radical from the problem. Now it looks like factored form, and Emma, when it's in factored form, how can you solve? Yeah, so you're just setting it to 0 by separating the two factors. So separate the first factor, separate the second factor. So when you have a radical, you want to get rid of the radical by squaring both sides. When it's factors, you split the factors up and then individually solve for 0. So if I solve this one, the square root of 0 is 0. It's not plus or minus 0, it's just 0. We don't have really a negative or positive 0. And then the other one here, when I solve, I get a negative 2. So kind of remembering how to get rid of a square root and what to do with those pieces to get be able to solve for both of those intercepts. So again, we have an intercept at 0, 0. That's an x and a y intercept. And then we have another intercept at negative 2 and 0. If you have a y-intercept at 0, 0, you're going to have an x-intercept at 0, 0. It's unfortunate. This graph should have kind of looked like a little curve. So it starts out here at negative 2, comes down, and then kind of shoots up. It doesn't go beyond the negative 2 because then you have a negative underneath the square root. Questions? Good question to ask. So we're actually going to do a couple of notes before we do the factoring. But I just want you to kind of, before you, I guess, close that up. The next worksheet for your homework, sorry, you may have already closed it up. You're only doing 1 through 5 today, which, yeah, it's just, okay. For some reason I was thinking it's like multiple parts. So you're doing 1 through 5. If you want to do more, you can. But you're going to have, like, the other part of that and a little bit of the next page for tomorrow's homework. So, like, tomorrow's homework will be to finish that, and then you'll be starting the next page as well. So if you like want to do more than 5, go for it because you got some extra time. I just don't know how many examples we're going to get to and if we get to those bottom ones. But if you remember how to do them, awesome. So tonight's homework is pretty minimal. For this morning, through Remind, I sent the assignment sheet for the week. When I send that through Remind, I also put any reminders about what's coming up test or quiz-wise. So today we have a factoring quiz, and then on Tuesday next week, you'll take the Chapter B test, which is the Tuesday after. That was also posted to Google Classroom on Friday. So anytime you're looking for that Google Classroom or Remind, and then the backboard over there, I also have it written there. Any questions? So as I said, we're going to do just a couple of notes here, and then I will give you some time to take that factoring quiz. We're going to take it at the end of the class instead of the beginning. So if you look at the first problem, the directions say to solve and then check, which means we want to see if there are any extraneous solutions in the problem. And we have x minus 10 absolute value equals x squared minus 10x. And I actually just reviewed absolute value with Honors Algebra 2 this morning. So that was chapter 1 that you did absolute value, except the absolute value that you did in chapter 1 was all linear. This one's a little more interesting because it has that quadratic on the other side. What do you do with absolute value to solve absolute value equations, Colin?
You have like 2 separate problems, and then you change the part that's not equal to, or not in the absolute value sense, you change it from like
gonna make those two separate problems. The first one stays exactly the same except you don't have the absolute value bars. And then Colin, the second one would be,
It would be the same thing on the left, on the right it would be x squared plus 10.
and you are so close. So close. Lauren, do you know?
That's how you get x squared.
Yeah, a negative x squared. So essentially you're taking everything on the right side and making all of that negative. So if there were 3 terms on the right, each term would have to become negative. Or in this case, the negative is already negative, so it becomes positive. It becomes the opposite. So now we have 2 equations to solve. Both of them are quadratic. What would you do to solve a quadratic equation? So Lauren, what would the goal be to kind of start this? Yeah, move everything to the same side, set it equal to 0. I like to keep my x squareds positive. So if x squared is positive, then I'd move everything to that side. That's my personal preference. It doesn't have to be yours. But I think factoring with a positive x squared is a little easier. So I would take the x to the other side with the x squared, and then add the 10. If you have a coefficient of 1 with x squared, that's like the most basic trinomial factoring. So Hannah, the 2 factors that would multiply to be 10 but give us negative 11 are,
Negative 10 and 1.
yeah, negative 10 and negative 1. So positive 10 and positive 1 would be the 2 answers on that side. So again, looking at the next one, my x squared is negative. I prefer to factor with a positive x squared. So I'm going to move the x squared now to the left. So it's a positive x squared. I'll move the 10x to the left. That gives us a negative 9x and then a negative 10. And Hannah, these 2 would factor as?
Negative 10 and 1.
So we get a positive 10 and a negative 1. So the last part, it says to solve and check. We really have 3 answers here. Both of them are 10. The 10 appears twice. But then we have a positive 1 and a negative 1. So we kind of need to see, are all of them solutions? Are 2 of the 3 solutions? Maybe 1 of the 3 are solutions. When you check it back into the original problem. So not the ones you created, but the original problem that you started with. And you're just taking the answer and plugging it back in. So 10 minus 10 is the absolute value of 0. 10 squared is 100 minus another 100 is also 0. So the 10 works, which if it's up there twice, that's probably a good indication that 10 is going to be an answer. Plug in the 1 to see if the 1 works. So we have 1 minus 10. 1 squared minus 10 times 1. So this is the absolute value of negative 9. And then on the other side, we have a negative 9. So I'm plugging the positive 1 in. Does the absolute value of negative 9 equal negative 9? No. This is wrong. When it's wrong, I usually place an X there, and then I cross off that answer. And then the last one, plugging in the negative 1. So negative 1 minus 10, again, into the original problem. Negative 1 squared, 10 times negative 1. So that's negative 11. And then over here, we have a positive 1 and a positive 10, so that's a positive 11. Does the absolute value of negative 11 equal positive 11? Yes. So I have 2 answers of 10 and negative 1. Again, sometimes 2 of the 3 would work, sometimes 1 of the 3 would work. All 3 probably wouldn't work, just based off of it being an absolute value graph. Questions? So see if you can look at the equation underneath. It says we have quadratic equations, which are the 3 underneath. 3 different kind of forms of quadratic equations there. And the first one says to solve by using the undoing method, which is kind of what we looked at for number 14. Nick, what do you think the undoing method means?
You have to expand the problem now.
So you could expand the problem out, that would be one way. So if it's a squared, you could write the quantity twice and expand it. What would be another method that you could use, Colin?
You could square root those.
We could square root both sides as well. That would be another method that we can use. Which one do you think would be easier? Yeah, probably square rooting both sides, because if you expand it, you've got a FOIL, you have to get it equal to 0. But in this case, if we just take the square root of both sides, it's a little less work. And I know you guys like doing less work. Yeah, definitely. So when you square root a square, they undo each other. Just like when you have 2 times x and you divide by 2. Multiplication and division undo each other. A square root and a square, they undo each other. You're just left with the x plus 4. Carrie, what is the square root of 36?
Plus or minus.
Nice. Didn't get tricked. Don't forget that when you take a square root, you have 2 answers, the positive 6 and the negative 6. This is a parabola, it's a U. So we should have 2 answers with our parabola. So one answer is going to come when you take the positive 6 minus 4. So Carrie, one answer would be
One answer would be 2.
2. And then the second answer is the negative 6 minus 4, which is
Negative 10.
negative 10. Nice job. So that's undoing. If you have something that's squared, you take the square root of it to get rid of that quantity that's squared. Questions? So number 2 is still a quadratic, but it says to solve it by factoring. Actually, it's not a quadratic, but it's a trinomial. We have x to the 4th, so it's called a quartic. X to the 4th minus 5x squared plus 6. I'm going to try and factor it. You can just use regular old AC because there's a 1 in front there. If you use AC grouping, it's not wrong. So you could use AC grouping as well. What's the power of x, Brenton? That's going to go in the factors.
X squared.
X squared. And then x squared, what goes next then, Brenton? If we have a 6, we're trying to make a negative 5.
Minus 3.
Right. Minus 2, minus 3. So we're still looking at those 2 numbers that multiply to be 6, that combine to be negative 5. So it's still like the AC grouping process. It's a trinomial, but the first 2 terms are x squared. Brenton, how would you find x then?
It's equal to x squared equal to 3. X squared equal
Yeah. So take your factors and solve for each of them. So Brenton, you would have
to x equals the square root of 2, x equals the square root of 3.
and what goes in front of both of those?
Plus or minus.
Plus or minus. Nice job. How many answers do you have here? 4. What's the power we started with? 4. So that power is an indication of how many answers you should have. The power of 4 means we should have 4 answers. Questions? So the last problem that is at the bottom here, still dealing with quadratic, says to solve the equation using everybody's friend, the quadratic formula. Why couldn't you factor this? Dylan, why can't you factor this? What's the process of factoring? If I wanted to try and factor this, what would you do first? Try and take out a GCF, which we can't. So what's the second step? Try to AC group. You get a negative 8. What multiplies to be negative 8? 4 and 2, or 8 and 1. Why don't they work? Right, none of them would go into negative 3. So that's when you say, crap, I gotta do something else. we're trying to use the quadratic formula here. You could also use completing the square, but that would get pretty messy for this one because then you'd end up having like crazy fractions. So, does anybody remember the quadratic formula? Dylan, you remember?
X equals negative b plus or minus the square root of b squared minus 4ac over 2a.
Wow. Nice job. The quadratic formula works for any quadratic problem. So you could always use the quadratic formula if you really wanted to use the quadratic formula to solve. But it will solve anything that is x squared. So when you're plugging the numbers in, the a is 2, the b is 3, the c is negative 4. See if you can plug them in and find the solution for this quadratic. Make sure you flip that negative 3 when you plug it into negative b, it's a positive 3. What number is under the square root? Josh, do you have a number under the square root? Yeah, 41 sounds good. Can you simplify the square root of 41 at all? No, it's prime. There's nothing else you can do to simplify this. Don't make it a decimal unless it tells you to make it a decimal. Which it probably only would say to do so if we were trying to actually graph those intercepts, and then we would want them in decimal form. Questions? So I think I'll stop there and give you about 15 minutes to take your quiz. Tomorrow there are 3 more questions on the back that talk about polynomials, so we'll go over solving those tomorrow. And then we're also going to start talking about solving inequalities tomorrow in our little review of interval notation. So for this quiz, I don't want you to use a calculator. There's no reason that you should need a calculator. You know, it's your security blanket. There are 7 questions, as I said last week. It's 16 points. So kind of look at the question first, assess the type of method that you would want to use. If you finish this early, feel free to start those first 5 problems. Again, 5 problems for homework tonight. So start those first 5 problems if you finish early.
Oh wait, my bad. My fault.
Make sure you place your name on the top. I don't have people's handwriting memorized yet, so place that name on there so I'm not guessing whose quiz belongs to which